My name is Aditya Vashisht and I'm currently studying in Information Science and Engineering Department at RV College of Engineering. And this is my demonstration of a PDA using the jflap application. So for the first question, I take my question to be for every design a PDA that is for every a raised to the power n, b raised to the power n, such that n is greater than 1. So here what we're saying is for every number of a's, there should be equal number of b's. If there are n a's, there have to be n b's. Having discussed the question, I will now proceed to make my states. So we have my states to be Q0, Q1, Q2, and Q3. And I will initialize my Q0 to be my initial state and Q3 to be my final state. And then I will draw state diagram, state transmissions. And here I take for Q0 to Q1, what we'll say is for an A, when we encounter an A and the base of the stack is Z, we will push the A onto the stack. We will push the A onto the stack is what we're doing here. Then again from Q0 to Q1 again if we encounter an A and this time the top of the stack is an A already, again we will push A to the stack. And again from Q0 to Q1, now if we encounter an B and the base of this and the top of the stack is an A, we will basically pop the A. So the lambda here signifies epsilon. So for every B you pop an A and every A you push into the stack. So the A's are being pushed and the B's are being popped. Again here what we'll do is for B, encountering a B, when the top of the stack is still an A, we will pop the A. And now from Q2 to Q3, that is the final state, what we'll do is when there's nothing left, we will let the stack have its initial state, that is Z0. So basically the stack will do nothing at this point. So for all A's, for every A, we will, for the A's are pushed and the B's are popped. Now we will try to run this simulation. So I will go on input. I will choose step with closure and I will put my input to be number 1. Let's say A and B. 4 A's, 4 B's, and I click on OK. And now when we do it step by step, so we first get an A, we go to Q1, again an A, so we push it in, again an A, we push it in, again an A, we push it in. Now next we encounter a B, so an A is popped, again a B, so an A is popped, again a B, so an A is popped, and again one more B, an A is popped. And now we have Z at the stack. So Z is at its so the stack is in its initial position. So when now we go to the state Q3 and our simulation ran completely. Now again I'll take an input which will not be the preferred language. So I take A and B. So 2 A's and 1 B. Now if I try to run it, A is pushed, then again at Q1 A is pushed. Now we encounter a B, so an A is popped. But right now we have A and Z at the stack in the stack. So when we reach our final state, it did not run the push down automata properly. Now I will be using one more question to demonstrate this push down automata again. So here I will take one more question to demonstrate. So again, I'm taking one more question to demonstrate my push down automata. This time my question is A raised to the power n, B raised to the power n, and C raised to the power m such that n and m are greater than 1. Greater than equal to 1. So here we have equal number of A's and B's, but unequal number of C's. So having said that, we will draw the states for these Q0, Q1, and Q2. And I will initialize my states, Q0 as my initial state and Q2 as my final state. Now I will put state arrows. So firstly, when we encounter an A and in the beginning, the first A, when the stack is at Q, we will push the A into the stack as we discussed before in the previous problem. And then again, when we encounter an A, when now this time when the stack is already at so again when we encounter an A on the stack, when this time the stack is already has an A, we will push the A into the stack again. So our next transmission goes to Q1. Here, when we encounter a B and the stack has A as its top node, we will push the A out of it. And again, if we encounter a B, when the stack has an A, we will pop it. Pop. So for the A's, we are pushing the A's, and for B's, we are popping the A's. When we encounter an A, we push it onto the stack, and when we encounter a B, we pop an A out of the stack. And after this, from Q1 to Q2, what we see is if we encounter a C, and the state of the stack is in the is in the Z state, that is the stack is in its initial state, we will do nothing and just skip it. So here we are doing nothing and just skipping the part where anytime we encounter an C, we do nothing, we just skip it. So again, we take C, and again we take Z, and again we take Z, we do nothing. So for A's, we're pushing it. For B's, we're popping A's, and C's, we do no such expression, we just skip the C's. Now we will try to test this. Let's take my input to be AA, BB, C, two A's, two B's, and a single C. And let's see what happens. So step 1, A comes at Q0. Step 2, A comes again at Q0. Step 3, an A is popped because we encounter a B. And again, A is popped because we encounter a C. And now we encounter a C. So it goes directly to Q2 because C will do no operation on the question. One more input, if we try with one more input here, let's say this time we take unequal number of A's and B's. Here now we take 2 A's, 3 B's, and 2 C's. Let's see what happens now. So we get an A, we're at Q0. Again, we get an A, so we push 2 Q's. On a B, we pop 1 A. And again, encountering a B, we pop 1 A. Again, when we find a B, we try to pop an A, but there is no A. So this shows that the statement where it's supposed to be A raised to the power N and B raised to the power N is being hindered. Therefore, it does not go to the final state. And this automata as language wasn't correct. So these were my 2 questions demonstrating the push down automata. Thank you.